Hey guys, welcome to Introduction to Functional Programming Scheme Edition. This is winter 2014 and seriously, thank you all for trying this out. Sorry these initial videos are coming out so late. We'll have them on time in the future. So, who am I? My name is Leela. Well, I'm a junior at GMU, and as some of you know, I'm also a UTA for the CS department and part of the Mason Triumvirate, a group of closely related student organizations. We're made up of Patriot Hackers, for which I was secretary, Mason's Linux Users Group, and Circuit, the student-run computing and technology group. I will also talk your ear off about things like ESOLings, like LOL code. Basically, these are programming languages that people came up with for fun, answering questions like, what if my program talked like a lolcat? But really, you don't care about that. You care about this little thing called Scheme. Scheme is a dialect of a language called Lisp, which stands for List Processing. It's the second oldest language next to Fortran, and it's still in use. Its siblings Clojure, Commonlist, Racket, etc. all live on, finding places in industry, research, and of course, academia. Scheme, however, is the simplest of these, where one must contend with 240 built-in functions in Python. With Scheme you only deal with like 67. More importantly, it is also used to teach functional programming and thinking. You know how in math, you can have a squared function? You put 2 in the squared function, you get 4. You put 4 in the squared function, you get 16. And if you do the squared function of the squared function of 2, then you'll still get 16 because that's 2 squared squared. Every time you put something into a function, it transforms your input to the output. Imagine programming everything like you would in math, by transforming your input from one to the other. That's functional programming. It avoids things like state changing and mutable data, making for often less confusing code, because every function you make will be like writing an expression in math. So, why do you care? What does that mean? Well, let's look at a thing that I did some time ago. What you're looking at here is a Hello World program written in BF. It's a dirt simple language. It's made up of pluses, minuses, square brackets, and angle brackets, and periods and commas. That's everything that's valid. White spaces, letters, numbers, they're all ignored. So, yeah. So, yes, you can do tons of things in languages like these, because it's still Turing complete. It's just a lot harder. So, my goal was to write an interpreter that would take these programs and then do the output. You know, not too terribly difficult, but it's still an interpreter. You still have to think about, okay, how do I parse it? How do I take the files? What do I do if they're invalid, etc. So here's my program. You know, the top here is the specs. If you're interested, go ahead and read through it, but I'm going to just skip to the bottom where the main function is. If you look here, the main function is called with the list of arguments passed in to the program. Main takes a whole bunch of files because that's what I'm expecting. These files are opened. If we look up here, open file will open it up and return the body of the program. And that body of the program will be thrown into parse. Parse simply takes the characters one at a time and executes what's under the characters. So, you know, if it does plus, then you call the increment function. If it does minus, you do the decrement function, etc. And if it's not there, then you just iterate. And all iterate does is go one further. Really simple stuff. There's a whole bunch of little tiny functions that do one thing well, like really, really well. But otherwise, you know, that's it. It's just really simple. A lot of this assignment doesn't really even have to happen. I just put it there because it's part of the Python style guide. It almost looks English-like, partly because you're in a high level language like Python, and the other half being, this is what functional programming usually looks like. It's almost as though you're just saying what you want, and then it happens. So, I hope that gives you a higher incentive to stick with this, because I really think everyone could benefit from this. Right, so syllabus. Do we have one? Yeah. If you go over to the class profile over here, you just pick the class you're in, hit the button next to QA, which is resources, and then hit syllabus. What comes out, it's a PDF of a very, very simple document that says what we want you to get out of this. Is there going to be exams? Only if you want us to make exams. Is there homework? Yeah, I put them directly into the slides though, so you can think about it as we go through. Are there going to be quizzes? Probably. They're going to be written by the other instructor, Brian Hoyle, and it's really just dependent on him. Other than that, the only other extra thing that we're really doing, besides these videos and then these videos and these slides, is meetups. We do Friday meetups most Fridays at 4 p.m. at the Potomac Heights building in the GMU Fairfax campus. So, what's the expectation we have of you? Well, you know, if you've got the time, give us a try, put in the effort, hang out with us on Piazza or at meetups. We want to make this fun for you and help you get something out of this that you can carry on to everything you do. But in the end, thank you so much for at least trying. And we hope that you find this worthwhile. Thank you so much, guys. Talk to you later.